All right. So you need to record 5 times for the bridge jump video. And let's say that my time was 1.62 seconds. Well, the equation for with acceleration due to gravity of how high the bridge is going to be is 16.087 t squared. So I would take my calculator, 16, not 19, 16.087 times 1.62 squared, and that gives me a height of 42 feet. Okay. Calculate the height for all 5 of your times. It's on your paper. 16.087 t squared. No, not at all. Not at all. Um, you don't even really need a decimal because of the way that this works. Okay. So we have our times, we have our heights, and then there's a chart, less than 40, 40 to 45, 45 to 50, and so on. Classify your times into the correct box in this table. So greater than or equal to 70. So I might have 1 here and 2 here and 1 here and 1 here. Whatever it is for yours, that goes in the top set of boxes. And then we're going to collect all of the data into one, and we're going to do it really fast by just holding up how many fingers. Okay. How many scores of yours were less than 40? Hold up fingers. Did anyone have one less than 40? How many fingers? Hold them up high. So 3, 4, 5, 4. Wait, hold them up again. Sorry, I'm laughing. 3, 4, 11, 12, 13, 14. So in the class chart, the second one, write 14. Okay, hold up how many fingers in 40 to 45? Hold them up really high. Up high, above your head. 2, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 27, 28. Okay, 45 to 50, above your head. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24. Okay, 50 to 55. High, above your head. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. 55 to 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 65 to 70. 1, 2, 3, 4, 5, 6. And did we have any over 70? 1. Oh, 4. Okay, 4. Wait, Josh, you had some less than 40 and some greater than 70? Don't trust him to run a stopwatch at the track meet because chances are he's not correct. Okay, so we now need to draw a histogram to match this, and Maybe we should do one 30. Did anyone have one less than 35? Good, one less than 35? Okay, what was it? 33? Okay, whatever. So, we're going to do our class intervals. We're going to put them all at a width of 5. And if they're all at a width of 5, then we can just graph the heights. So, I need to go as high as 30. So that would be 10, and that would be 20. So my first one that ends at 40 is going to be up here at 14. My next one that ends at 45 is going to go all the way up to 28. All right, and the next one ends at 50, and it's going to go up to 24. And then 55 up to 17. And then 60, we go up to 14. Oh, that last one's a little short. There we go. And then 6. Oh no, wait a minute. Did I mess up? 55 to... Oh, shoot. The worksheet's wrong. Okay. Sorry. 60 to 65, my worksheet's wrong. 65 to 70, I'm missing a box. And then 70 plus. Okay. Count up your 60 to 65. No. Oh, so this is a 10 now. Okay, 60 to 65. 1, 2, 3, 4, 5, 6, 7. And then how many did we write on 65 to 70? 6, and then 1 out here. Okay, sorry about that. I need to update my worksheet. Oh yeah. Okay, 65 up to 7. And then 70 is up to 6. And then 4, 70 plus. Okay, wow. Would you say this data is normally distributed? Not really. It's not, which surprises me. I would expect it to be normally distributed, but it didn't end up being that way. Okay. What would you guess the actual height is? So the median probably sits about right here. In this data, where is the average compared to the median? It's going to be slightly to the right. So this would be the average. Okay. Because it has a long right tail. So would we guess the median? Half the scores are above this, half the scores are below this, or would we expect the average? What do you guys think? Probably the median would be my guess. Okay, should we just throw out the highest and lowest numbers because those people obviously should not be trusted with a stopwatch? In this case, does it make sense to throw out the ones that are far on the ends? Probably. I would be okay with throwing those out. Now, weighing NB10, do we throw them out? Those aren't, it's not a person making the mistake. It's the scale just came up funny. And maybe where you put the weight on the scale affects the weight of it. But this idea of throwing out outliers, it's just difficult. Do we do it or do we not do it? I don't really know. Okay. Next page. Calculate the average of the heights from your 5 measurements, record it in the blocks below, and then go around and talk to 9 other people and get their averages and put all of those averages together. So find the average of your 5 heights, write them down, and then go and talk to 9 other people and get their averages and record those on your paper. Okay, get to work. I have recorded 10 of your measurements, and if you look at them, 38.4 is the smallest and 61.3 is the largest. That's pretty big. What was yours, Josh? Because your 70 was so big, it actually kind of worked out. Okay. So how many of you, when I find my average of my averages, I end up with 48.8. Would we expect this number to be closer or further away from the true average? Closer. The more people you include in this, the more accurate you would expect the answer to be. So how many of you had an average of averages that was less than 48? 1, 2, 3, 4, 5, 6, 7, 8. So apparently I talked to people that were slow on the button push. How many of you had averages that were between 48 and 50? 1, 2, 3. How many over 50? Just one. Okay. Now, do you start to see the variability when you gather data? So let's talk about this in terms of chance error and bias. Somewhere out there, there is a true height of that bridge. Okay. What kind of bias might exist when you are making these times? When you start and stop, do you try to anticipate and push the button when you know that I'm going to jump, or did you see the jump and then push it? That's bias, right? What about hitting the water? Are you timing the sound, or are you timing the splash? Or do you anticipate the sound, or do you anticipate the splash? Okay. So what about chance error? What would chance error be in this case? Okay, you missed. We are just not very accurate with pushing buttons, right? Nobody, no, no track meets are timed with a stopwatch anymore. They're all done with some sort of computer that times the start and the stop, because we're just not very good at that. Okay. So down near the bottom, can we safely assume that the final average height is the correct height of the bridge? No. Because even we had a whole bunch of people that were less than 48. We had a couple people that were between 48 and 50, and we had one person over 50. Now, I did this last year, and we got totally different numbers than we did this year. I used a video timer to time the video. And the bridge is, anybody want to guess? 52 feet high. So good job, Dalton. You talked to people who knew what they were doing. So apparently, you guys are early on the button push. You either start late or you ended early or both. When I did the video timer, I ended up with 52 feet. Yeah, what could we do to be more accurate? You could actually use a video timer. Now, is that going to be correct? What if the record and the play of the video are not truly the same length? Does that make sense? What if it records 24 frames per second and then it plays it back at 25 frames per second? That's going to change things. Okay.